Now we move to Ullmann reaction. Ullmann reaction is a reaction in which aryl halides in presence of copper at elevated temperature undergoes coupling reaction to form biaryls. So we could say in Ullmann reaction, two molecules of aryl halides undergoes coupling reaction in presence of copper at higher temperature to form biaryls. See here, I am taking a substituted iodide, aryl halides, treating with copper so that I am getting substituted biaryl. This reaction is called Ullmann reaction. See, this is a nitro substituted aryl chloride. It undergoes reaction with copper at higher temperature to form substituted nitro substituted biaryls. So this reaction is called Ullmann reaction. Please write down and follow me. Don't take screenshots. Take down. So moving towards the mechanism, we could say the first step is the formation of an active copper species. This is the active copper species by the introduction of aryl halides with copper. So we could say this copper will get inserted between carbon and iodine so that copper is getting oxidized. So it is an oxidative addition. So the oxidative addition occurs, and from the oxidative addition iodine will be released out. So I will get a active copper species. This is the first step of the mechanism. So we could say in the first step an active copper species is formed by the interaction of one of the aryl halides with copper powder or metallic copper. So oxidative addition occurs followed by elimination to form copper active species. In the second step, these active copper species undergoes oxidative addition with second molecule of aryl halides. So this active species again undergoes oxidative addition with another molecule of alkyl halides, so that this copper get oxidized to Cu+2. So oxidative addition occurs. This is finally followed by reductive elimination to form the biaryl. So from here the copper iodine will be eliminated so that this carbon-carbon ring connects to form the biaryl. So this is the reaction mechanism. Take down. See another example. Here I have a substituted aryl halides, nitro substituted halides. So it reacts with copper to form oxidative addition, followed by elimination to form an active species, active copper species. This is the first step. This active copper species further react with another molecule of aryl halide, substituted nitro substituted halide. So we should get a oxidative addition product which undergoes elimination to form the final product. During this reaction, the product formed could be attrop isomerism type. Attrop isomerism type, it could be formed. Take down. Now we move to another reaction, that is Dickmann condensation reaction or Dickmann cyclization reaction. It is a intramolecular reaction of diesters. Diesters undergo intramolecular reaction in presence of a base to form beta ketoesters. So usually the diester undergoing Dickmann condensation reactions are alpha omega diesters. They undergo condensation to form a cyclic beta ketoesters. And the reaction is apt or good for 5 to 6 membered cyclic beta ketoesters. And usually the base used is sodium alkoxide. See here, this is the reaction. I have an ester at the alpha position and an ester group at the omega position. That means the first and the last position. So these two esters in presence of base undergoes intramolecular cyclization. So a cyclic compound is formed. The resulting product is a beta keto ester. That means one of the ester group is maintained while another ester group is converted to a cyclic ketone. This reaction is called Dickmann condensation reaction. See another example. The number of carbon atom is less here. This is diethyl adipate and I am getting a pentacycloketone. Take down. So the mechanism shows that in the first step, the base, that is C2H5O minus ion, abstracts the H plus, that is the alpha proton of the first ester group. So OR minus abstract the H, and as a result the first alpha carbon atom of the first ester group gets a negative charge or a carbon ion is formed. This negative charge on the alpha carbon atom of the first ester group attacks the carbonyl carbon atom of the second ester group, that is the last ester group, releasing OR minus group. OR minus group. Then again the base abstracts the H plus from the alpha carbon atom of first ester group, followed by H plus acid workup to form the final cyclic beta keto ester. So check the mechanism here carefully. That animation you see, I will explain. See here, not this one. This is the second step. Wait, just wait. Check the mechanism here. See, this is the alpha hydrogen atom. This is the ester group. This is the alpha carbon atom. See, it is abstracted by the base OR minus. So a enolate is formed. Now this carbon atom, see, that carbon atom get the negative charge and attack the carbonyl carbon atom of second ester group, and OR minus is released out. Now here we have a hydrogen atom, that is the alpha hydrogen atom. The base again will come and abstract this hydrogen atom. See, second base. As a result, an enolate is formed. Double bond O minus, enolate is formed. Now H plus will come, attack this particular center, and resulting the formation of the final cyclic beta keto ester. See the mechanism once again. See that this is the alpha carbon atom or alpha hydrogen atom. The base is coming and abstracting it, so that we are getting a negative charge on this particular carbon atom. This will be rearranging double bond O. So this is negative charge on this particular carbon atom. It is attacking the carbonyl carbon atom of second ester group. OR minus is released. Now here we have another H. One more H is there. The base will come and take this H, so that again an enolate, cyclic enolate is formed. See, double bond O minus. Now H plus will come. It will rearrange to form the final cyclic beta keto ester. See, we could explain the mechanism without animation here. So this is the base ethoxide ion. It is abstracting the alpha proton of the first ester group. So this is the ester group, and this is the alpha carbon atom, and this is the alpha hydrogen atom. So the base is abstracting this one. As a result, an enolate is forming. Double bond O minus, enolate ion is forming. So this is a carbon ion. So this negative charge will be shifting towards here. As a result, this double bond shift to this carbon atom. This is the alpha carbon atom, which is having a negative charge. This negative charge is attached to the carbonyl carbon atom of second ester group. This is the carbonyl carbon atom of second ester group. So a ring is forming between the alpha carbon atom and the carbonyl carbon atom. So here establishing a ring. So O minus, the electron is shifting towards here. As a result, OR minus is eliminating. So we are getting a cyclic structure. Now again, this OR minus abstract the alpha hydrogen atom. Again, we have an alpha hydrogen atom there. Then this will be shifting to form an enolate ion. This enolate ion absorb H plus ion to form beta keto ester. This is the ester group, and this is the alpha carbon atom, and this is the beta portion. So we are getting a beta keto ester. Got the point? Take down, very important. Now move to Chichibabin reaction. Chichibabin reaction. You might have heard this reaction. I think so. So this reaction is to introduce amine group to the nitrogen containing heterocyclic compounds like pyridine, quinoline and isoquinoline using sodium amide as the reagent. So in Chichibabin reaction, amino group is introduced to the second position of a heterocyclic compound having nitrogen atom. This reaction is called Chichibabin reaction and it is usually used to introduce amino group to pyridine, quinoline or isoquinoline type compounds. See here, this is pyridine. To this pyridine, we are using NaNH2 so that NH2 group is introduced to the second position of the heterocyclic compound or the nitrogen atom. So this reaction is called Chichibabin reaction. Take down. The Chichibabin reaction proceeds through the formation of an intermediate called Mesenheimer adduct. In Chichibabin reaction, a Mesenheimer adduct is formed. And what is a Mesenheimer adduct? A Mesenheimer adduct is a 1:1 adduct between an arene carrying electron withdrawing group and a nucleophile. So this is an arene having a electron withdrawing group here and it is combining with NH2 minus which is a nucleophile to form a adduct. So the reaction proceeds due to the formation of this Mesenheimer adduct. That is, in the first step, NaNH2 decomposes to form NH2 minus and Na plus. This NH2 minus group adds to the polarized ring carbon atom, that is the second position, so that this electron pairs will be shifting towards the nitrogen, so that this carbon atom generate a positive charge and NH2 minus attack this position and resulting the formation of a adduct, anionic adduct, because this nitrogen carries a negative charge. To neutralize it, we have a Na plus ion. So this is or these two are example for Mesenheimer adduct. So in Chichibabin reaction, the first step is the formation of the Mesenheimer adduct. Take down. Now see here, the electrons from the NH2 group attached at the second position are then pushed so that H minus will be eliminated. That is a hydride ion elimination occurs. See here, to the second position, the NH2 group has attacked and the nitrogen have a lone pair of electron. This lone pair of electron enters into the ring nitrogen bond or carbon nitrogen bond. So a carbon nitrogen double bond is forming and H minus will be eliminated. See here, H minus is eliminating. This eliminated H minus ion, abstracts hydrogen from positively charged NH2 group. See, this NH2 group becomes positive, so that the H minus ion left from this ring abstract the H plus ion of the ring. As a result, we get a carbon double bond NH. See here, the positive charge has neutralized. Now, to regain the aromaticity of the compound, the lone pair of electron present in the ring nitrogen is donated to the ring, so that carbon double bond NH get polarized, so that the nitrogen get a negative charge, which abstracts H plus from the medium to form the final product. See carefully. First step, NaNH2 decomposes so that the NH2 minus group attack the ring carbon atom due to the polarization of the ring nitrogen atom. So a Meson-Hammer complex is formed here, and the lone pair of electron present in the NH2 group enters between the carbon nitrogen bond, eliminating H plus ion, H minus ion, a hydride ion. This hydride ion again abstracts H plus from the NH2 group. See here, H minus abstract H plus from the NH2 group, so that the nitrogen gets neutralized. Now the ring is not aromatic. To regain the aromaticity, the lone pair of electron present in the nitrogen is donated to the ring, so that nitrogen gets a negative charge by losing carbon double bond N bond. So carbon double bond N becomes carbon single bond N. This NH minus abstract H plus from the medium to form the final product. Take this step one by one clearly, very, very important. Now complete the reactions and identify the products. Take down the reactions. NaNH2 in presence of basic medium. So identify the products.